Kate Sweden. His mathematical interests lie in combinatorics and patterns and possibilities. Basically, we can say that he loves permutations combinations.
Yeah, thanks a lot for that. And I really like the basically he likes permutations, combinations. And that, yeah, that's wonderful because that is a lot of what we are going to talk about also today. So hopefully it will be fun. Okay, so the sort of thing that we are planning to do today is, uh, I would say, rather just a type of question is what we're going to look at rather than a specific question. So in that context, I mean that's basically why the title of this these two sessions that we're going to have together is just called "How Do I Count?" So, okay, so one more practical thing before we start, I would like to say that hopefully, so the plan is that I'm going to talk to you about some problems and more that you try to solve the problems and I just guide you rather than me just showing you the solutions to the problems. So, if possible, please try to have some writing material with you, some tablet, paper, pen, whatever, just something so that you can do some rough work. So that is one practical thing I would like to say. And okay, so at least the organizers have sort of warned me that there are some sessions where you are uh, participating a lot with the things in the chat and stuff like that. But I do want to start this session with just asking you whether you have any opinions about counting problems. And before asking you for your opinions, I'll just sort of just to make sure everyone knows what counting problems are. It's basically something like you are given uh, a bunch of objects and you are asked to count them. So, of course, this is nothing of a very formal definition. Of course, these objects might be pretty weird. It might not just be objects, it might be possibilities of something that could happen. It could be something like, uh, I have 35 chocolates, I have to distribute them among 15 people. How many ways do I have to do that? So it is just basically where there are certain possibilities and you have to count these possibilities. Okay, so these are the kinds of questions. Maybe something like how many numbers from 1 to 100 are divisible by 7? These sort of questions. Okay? So what I want to first ask you, because I definitely had an opinion about this when I was in school. What opinion do you have about counting problems? Do you have any experiences or something about counting problems that you want to share, either good or bad? That's all completely fine. But just before we start, I want to get a feel of what you think about counting.
Yeah, sure. Shraddha's raising her hand. Shraddha.
Sir, I like combinatorics. I like to solve combinatorics, but sometimes the questions that I solve kind of works me out, and I get like a feeling of how much do I have to count more, and is there any easier way I can do this, and then it gets kind of tiring. But combinatorics has been one of my favorite topics in math to solve.
Yeah. Thanks, Shraddha. That I think is, yes, I have heard this opinion a lot. And hopefully, as we work through the problems in this session, maybe, I don't know, maybe you might feel like the problems are annoying you even more, but hopefully, at least there will be other problems that you will like. Yeah. So thank you, Shraddha. Is there anyone else? Maybe one or two more opinions, then we'll
Yeah,
get started.
Ayan, can you?
So for me personally, counting problems are like one of the easiest types of problems in math, but sometimes they can feel tiring. Like, sometimes they feel a little annoying kind of.
Okay. So just one quick follow-up to your comment, Ayan. So what exactly about counting problems do you think make them easy?
Like they're very simple compared to other questions, like
Okay.
fractions or any other things. Operations.
Okay.
Easy. They're simple.
Okay. So yes, so that is nice to hear that some people do find counting problems nice and simple. Uh, so maybe we'll have one more opinion and then we can
Yeah, Kavin.
start.
Yeah, so counting problems are, I don't think they're annoying, but I would say it's more interesting. So we need to find the factors so that we can like reduce the number, no, like reduce time so that we can count them more fastly. And we can see the number of possibilities in which we can count them like that. So I don't think it's annoying. I
Okay.
actually like it. It's interesting.
Yes. Okay. So that is great. So we will have some more opinions in the end of the second session. So for now, we won't take any more because hopefully I would like to present some counting problems. Then maybe you have changed your opinion, maybe you haven't, but let's see what happens. But one thing that at least I really felt before I started getting interested in combinatorics was that I used to be scared of counting problems because I thought it's very easy to fall into a trap of, oh, I think this must be correct, and then I start doing some stuff. Then someone points out to me, oh, no, this logic that you used was incorrect. So, but the one thing I did like even before, and of course I do now as well, is something that Ayan mentioned, which was the simplicity, which is that these are problems that you can understand quickly. So you don't need to know a lot. You don't need to know a Pythagoras theorem. You don't need to know that the sum of the angles of a triangle or this. So it is easy to understand the problem. And what I would say, quite importantly, it's easy. You can also play with the problem, okay, which is something that combinatorics really allows you to do. Okay. So with that, let us start with what I was planning to do. And let's see whether any of the opinions that we have change throughout the course. Okay. So yeah, the first thing I'm going to say is there are something, so the things that I'm going to talk about for some of you might be simple, for some of you might be difficult, but I don't want anyone to feel like they are like, I don't know, the things are too simple or the things are too difficult or stuff like that. So for those of you who maybe already know the problems we're going to do, or even you're not interested in the problems that we are doing in the session, I'm going to share a link of some other problems that I have written down. So I'll share it in the chat. So it is a Google Drive link, so you can just open it and there will be a PDF over there. Of course, I would suggest that you wait for the first one or two questions that we look at and then decide whether you want to look at these extra problems or not. Okay, but this also could be some problems that you can look at after the sessions if you are interested. Okay, but now let us start. So,
Sir,
yeah.
what are we exactly going to do?
Yeah, we're going to look at counting problems. So what I'm going to do is show you one problem after another, and I'm going to ask what ideas you have to solve them. Okay? And hopefully, if I've chosen the problem correctly, I'm trying to also sort of give you a procedure of how you would tackle any counting problem. Okay? But that is, uh, there is no such procedure really. I mean, each problem is different, but at least a sort of broad outline of what you could try. Okay? So let me just start with the first problem. Then I will, hopefully things will be clear. Okay. So the first few problems that we are going to look at have to do with towers of boxes. Okay. So we're going to count certain configurations of towers of boxes. And the first thing that we are going to do is the sort of simplest case where you have two towers. Okay? And what we want to count is something like this. Okay? So how many ways are there to put, let's say, 5 boxes in 2 towers? Okay? So what I mean by towers of boxes and stuff like that is, so for example, one such configuration would be, say in the first tower, I have, I don't know, 2 boxes. And in the second tower, I have 3 boxes. Okay? So this is tower 1 and this is tower 2. Okay? So there are a total of 5 boxes, right? So the question is,
Sir, I
if
have
I
a
want a total of 5 boxes, yeah.
So my doubt is, can one of the towers have zeros? No, right?
Wonderful. I was very much hoping that someone would ask this
Yeah,
question.
because you have to find the
Because
complements.
not exactly for that reason, but the reason that I was hoping someone would ask this question is the first step when you see a counting problem is, I think, the most important step, which I will now write down. So step 1 for counting. So this is for any counting problem. The first step is understand the objects. Okay. So this is exactly it's a great question to ask. Can a tower have 0 boxes? Okay, because then the objects that we're looking at will change, right? Depending on whether I answer yes or no to that question, right? So for our question, we're going to say each tower must have at least 1 box. Okay, so I will not allow a tower to be empty. Okay,
Then okay,
I
sir.
mean,
Thank you.
yeah. But I'm very glad that you asked this question because I really wanted to bring up this point. Okay.
Thank you.
Because in any counting problem that you try, the first thing is make sure that you understand the objects. Okay. Because if you don't understand the objects, then you don't know what you're counting. Right.
Sir?
So,
Sir,
So can I answer?
Sir, I have a doubt.
one second, Kavin, a doubt I think is, yeah. Shraddha, what's your doubt?
So my doubt is, so suppose you have boxes numbered 1, 2, 3, 4, 5. Can 1, 2, 3 be tower 1 and 4, 5 be tower 2, and then 1 to 4 be tower 1 and 3, 5 be tower 2? Can it be like that?
Okay. So you're asking, so suppose
Like the towers are of the same length, but they have different boxes. So you're muted.
Oh, sorry, I don't know how that happened. Okay, so are you asking whether these two configurations are different?
No, sir. They tower tower. Say the first example, tower 2 still has 3 boxes and tower 1 still has 2 boxes, but they have like different. They don't have a different number of boxes. They have different boxes. Like.
Oh, okay. So no, we are not going to distinguish. We are not going to number the boxes. For example, the things that you have to count do look like these diagrams over here. So there are no numbers in the boxes or anything. It is just like these empty boxes that are here.
Sir, will we count ordered pairs like the one you just drew? T1 has 2, T2 has 3, and then in the next form, T1 has 3 and T2 has 2. Will we count that
Yes.
as the same or will it be different?
So these are different. So
Okay.
this and this, these are different. Okay, because we care about what is in the first tower and what is in the second tower. The two towers are different. Okay, so in this first example over here, the first tower has 2 boxes, the second tower has 3 boxes. Whereas in this example over here, the first tower has 3 boxes and the second has 2 boxes. Okay? So it matters sort of the order of these towers. Okay. Okay. So now what I want you to do is for this number 5, try to draw all the possible ways in which these you can fill in boxes in these towers. And after about 1 or 2 minutes, I'll ask you what you think the answer is. And then we'll see what more we can do with this kind of problem.
Sir,
Sir,
Yeah.
Shraddha is asking whether we can make a table.
Make a table. Oh, so for the answers? Yeah,
Yeah.
sure. However you want to write the answers, that is up to you.
And we have a lot of active hands raised here.
Okay, then sure. Let's
I think
go ahead.
no, wait a second. I mean,
Yeah.
okay, fine. If you want to take answers, we can take answers. Should we?
Yeah, because yeah, 1 second. I'm just reading the chat
I
also.
think what Dhairya meant was everyone lower your hands, take some time to think, and then get back with the answer.
Yeah, I mean, I'm saying let everybody else in the session also think and answer for themselves.
sir, I have doubt.
Sir, I have a doubt.
I have also doubt.
Okay, fine. Then
Yeah,
we'll
sure.
just take doubts one by one. Sure.
Can I say? Rudra can say.
Everyone without a doubt, lower your hands, and then after that, Rudra, start with your doubt. Okay?
Yeah, like, can we just reverse and it will count as one, like, T is one and T2 is one, and like, we reverse them.
No. So I do care about how many are in the first tower and how many are in the second tower. So for example, just like in these two over here. So in this configuration, the first tower has 2, the second has 3. But this will be different from this configuration, where in the first tower I have 3, in the second tower I have 2.
So this will count. No?
Yeah, so these are 2 different things. They are not the same.
Thank you.
Yeah, sure.
Okay, Ashwath, what's your doubt? Pragnya? Fine. Kavin, what's your doubt?
Sorry, I forgot to take my hand. Sorry.
Oh, okay, fine. Adrit?
Sir, can we do it in decimals? Like, does it have to be natural number, the number of boxes on a tower? Or can we do it like 2.5 and 2.5?
No. Please don't chop up any boxes.
Can
Leave
we
the
use
boxes there.
more than 2 towers?
Yeah.
Wonderful question. But we will come to that after we solve this question. In fact, that is exactly what we're going to talk about next. What if there are more towers?
Abhinav?
But
Yeah. Sorry, sir.
No.
Abhinav?
I just want to answer.
Lower your hand and we'll take answers later. Ishan?
Sir, we can have 2 towers like 0, sir.
No. So I will at least for this problem, we will insist that every tower has at least 1 box. So you can't have an empty tower.
Okay, sir. Thank you, sir.
Yeah. Okay,
Advait?
so if there are no more.
Advait, do you have a doubt? Advait? Okay.
Yes, sir.
Yeah, do you have a doubt?
Yes, sir.
Yeah, please. Please go ahead.
Sir, for this type of splitting a number n into 2 natural numbers, that is a natural number n into 2 other natural numbers, then I have observed that there are n minus 1 by 2 ways of splitting the numbers, sir.
Okay, so let us maybe look at this. So I guess this is more of an answer than a doubt, but let us, I guess, if there are no more doubts, then we can start looking into answers. So,
Sir, but for rather than being n minus 1 by 2, we can make like 3 by 4 can also be made as 4 by 3, sir. So we are like, when you're doing 1 by n minus 1 by 2, we are also like taking 3 by 4, 3 plus 4 only 1, sir. So rather than doing by 2, we can just do n minus 1, sir.
okay, so let us, in fact, instead of talking about general situations, let's see if it works for n equal to 5 first. So this concrete problem that we have over here, where we have these 5 boxes where we have to split into 2 towers, what are the possible ways in which that can be done?
Can I say, Can I say Kabin?
Okay, Kavin seems
I'm
very excited.
okay.
Let's just let him answer.
Yes.
Okay, sir. Okay, sir. So first in the sum, here we can say 0 is not possible. That means that 5 is also not possible. Then 1, 2, 3, 4 is should be the number minimum maximum number of boxes in the each of towers. So we can split like 1, 4, 2, 3 and the vice versa. That's all.
Yes. So first off, so I drew these towers of boxes just so that to see if you keep talking about towers of boxes or you convert to numbers. But at least from the chat and from what people are saying, hopefully a lot of people are now just converting it to numbers in their head. So, but at least for the first one, I will draw the different possibilities. So what Abhinav just said was that basically you can do tower 1, tower 2 with 1, 4, or you can do what we have already seen, 2, 3.
Yes, and the vice versa, which is exact opposite. Tower 1 will be 4 and the other will be 1 like that.
Yes. Oh, sorry.
That can only be the answer.
So I've sent my answer to you on the.
1 second, let me just make sure. So this is what Abhinav has said, that there are these 1, 2, 3, 4 possibilities. Is there someone who disagrees with this?
Sir?
Yeah.
Sir, I don't disagree with this, but I have a slightly different way of doing it.
Yeah, sure. Go ahead.
So it's actually based on this, but I while solving this problem, I like devised kind of a formula kind of thing, which would help you find the number of these towers you can make for only 2 towers with any number of boxes.
Okay, so maybe 1 second, you hold on to that. We'll come to that. But does anyone disagree with the fact that there are exactly 4 answers to this question if you have 5 boxes? Does anyone disagree with that? Does someone want to say 5, 3, 42, some other number?
If you disagree, please raise your hand. Otherwise, lower it.
We look like we have three disagreements. No, 2 disagreements. Rudra and Advait. So let's start with Rudra. Okay,
Sorry,
please.
sir, I raised my hand by mistake.
Okay,
I
okay.
agree with the 4, like 4.
Yeah, fine, sure. Advait, you have a disagreement?
Sir, a slight disagreement, sir. If it is regarding numbers, then it's only 2, because you're not numbering the numbers as 1 and 2. This is the first number and this is the second number. You're not numbering those numbers. While for these towers, you're doing so. So for the
Okay,
towers,
so
there are 4 ways, and for the numbers, there are 2 ways.
okay, but I have a slight disagreement with your disagreement because so the fact that I am saying towers and I care about the order. So the reason that I mean I get your point that if the order did not matter, there would be two uh, answers. But it is not always the case that even if I'm dealing with numbers, that the order does not matter. Okay? So, for example, just think about an actual situation. Suppose I have to give you and your friend 5 chocolates. If I give you 4 and your friend 1, would you say that is exactly the same as you give me 1, give my friend 4? I mean,
No, sir.
you would argue, right? So
No, sir.
this is what I'm just trying to get at. That I mean, I get your point that if you just care about how you're splitting the number, then yes, what you said is valid. But this is basically the first point. Try to understand what you are counting. Okay? Then your instinct is good. After you have completed the solution for one problem, your instinct of thinking about, okay, what if the problem were different? That is a very good instinct. Okay.
Okay, sir.
Yeah, but thanks. Yeah. So I guess everyone agrees with this answer that there are 4 possibilities.
Any,
And
yeah.
Sorry, I raised my hand. I missed it.
Yeah, fine. So continue, sir.
yeah. So one thing we're going to do more for my sake than anything else, because a lot of you are talking about numbers, not going to sit and draw towers of boxes anymore. We're just going to write down numbers. And the way we're going to do that is just, so this we will write as a pair 1, comma 4. This we will write as the pair 2, comma 3. This we will write as the pair 3, comma 2. This we will write as the pair 4, comma 1. Right? So all I'm just doing is recording the number of boxes in tower 1 in this first place over here, recording the number of boxes in tower 2 in this second place over here. Okay? So does anyone disagree or have any questions about this change of notation that we are doing now?
Sir, excuse me, sir. I agree
Yeah.
the question, the answer is correct, but can you tell like any easier way so we can't do it manually, like any formula?
Exactly. So now, okay, so now this is coming into if you have a problem like this where you have to count some stuff. Okay, for 5 boxes it is fine, but what if I gave you 500 boxes, right?
Yes.
Then I would not expect you to sit and write down all the different solutions. So the first way that I would suggest that when you have a counting problem, what you can try is do the problem, actually do this computation for some small numbers. Okay. So for example, here we did it with 5, and I hope everyone agrees that it doesn't take too long to figure out that there are 4 solutions for a concrete number 5 that I'm giving you. So what I would suggest that you do is make a table like this. Okay. So step 2 of do examples. Okay. So basically what this is in this case, it means for 5 boxes, we have an answer, how many ways you can split. But okay, what about 6? What about 4? What about 3? What about 7? So for these number of boxes, what are again now the answers that you get? So this is what I would, so this is not a question I'm asking you, you don't have to raise your hand. So what I would suggest that you do is just do examples and try to find patterns. There will be a sort of asterisk, sort of a sub step corresponding to this, which I will talk about in a while. But usually in counting problems, what I would first thing maybe to try is this, but there is something I'm going to tell you about this step which you should be careful about in the future. But for this problem, what I would suggest you try is just see if you can see any patterns. For example, let's see. So let's say n is the total number of boxes. So for n equal to 5, the possibilities we have is 4, and this we have written down over here, these 4 possibilities over
Sir,
here.
there's actually two different answers of this question. Whether or not you're mentioning whether it's distinct or not.
What is distinct?
Like indistinct or distinct, like A and B or no like specific groups. If there are no specific groups, then there will be only two numbers.
Okay, yeah, but that we already decided, right? That we do care about the order of the numbers. So in this problem, we do care about the order of the numbers. So for example, 3, 2 will be different from 2, 3. Okay? So that is the problem that we are looking at.
Sir, Saranya has a doubt.
Yeah, sure.
So if there are 6 boxes and you have to arrange that in 2 towers, can I also put the 3 boxes in each tower?
Yes, of course. So both the boxes have both
Because
the towers have 3 boxes.
in the combination of total 4 boxes, we had that the 2 towers are different.
Okay. So that is not we won't restrict to that. For example, let us try now 4 boxes. So if we have n equal to 4 boxes, then the possibilities are 1, 3.
2, 2 and 3.
Yes, and 3, 1. So there are 3 possibilities. Okay. So I hope everyone agrees with this for n equal to 4. And so we can write down this number over here. There are 3. And then, so my point is basically, if you are not seeing what the answer should be, then what you could do is just try for different number of boxes. So the first thing we looked at was if there are 5 boxes, what is the number of possibilities? We have just seen now for 4 boxes. So try to see for 3 boxes, how many possibilities? For 6 boxes, how many possibilities? And once you write down all these numbers, hopefully you will see what
is n minus 1.
Okay, so it is good that you said that, but so if there is anyone who is still not sure about the answer, I would suggest that you try doing this. So at least for these numbers, 3, 4, 5, and 6. 5 we have already done, 4 I quickly wrote down. So try for these and fill in the number of possibilities over here. Okay. So I'll give you some time to do that. And once you have done that, we will discuss about what the general answer would be and what it also means, a general answer. Okay, so from the chat, at least I'll fill up these numbers. So this is what I've seen so far. I don't think there is anyone who has written anything else. But so for 3, if n is 3, then there are 2 possibilities. And And if n is 6, people are saying that there are 5 possibilities. Okay. So is there anyone who disagrees with this?
No, sir, it's correct. I also got that.
Okay.
So I couldn't understand what we
Sorry, someone said they don't understand. Okay. So what we are doing is okay, let's go back to the beginning. So for 5 boxes, we were looking at how many ways there are to break up these 5 boxes into 2 towers. Okay. But after figuring some stuff out, basically what we have to do is find out the number of such pairs. So you have a pair consisting of 2 numbers. Both of these numbers are natural numbers from 1, 2, 3, and so on. And their sum should be 5. Okay. So that's why if I wanted, say, n equal to 5, then the possibilities are 1, 4, 2, 3, 3, 2, and 4, 1. Okay. And with some working out, I guess you can sort of convince yourself that these are the only 4 ways in which you can do this. Okay. So the visual way that we looked at it was these towers of boxes. So the only reason I'm mentioning both is because some people are more happy with visual stuff, some people are more happy with actual numbers, but whichever you prefer, that's completely fine. So now this was the answer for n equal to 5 when the total number is 5. But now the question is, okay, what if now there are only 3 boxes in total? Then how many ways can you sort of do this splitting up into 2 towers? Or in the numbers way, how many ways can you write this 2 pairs of natural numbers whose sum is 3? Okay? So that is what we are doing. So for example, for n equal to 4, again we wrote down the solution and there were these 3 solutions. So 1, 3, 2, 2, and 3, 1. So there are 3 possibilities. Okay? So that is what we were doing for all these different numbers now. So I hope whoever asked the question, it's now clear what we are doing, or
Yes.
okay, maybe two. Okay, so now we'll sort of take the general answers and whatever comments you have.
Sir,
Yeah, sure.
sir, I disagree the possibilities for 6 and 5, sir. 6 boxes 5, sir, because it will be 1 and 5.
Okay,
2
so
and
let's
4.
write down the answer for 6. 1 second. So can you start again? What are the possibilities?
1 and 5.
1 and 5.
2 and 4.
2 and 4.
3 and 3.
3 and 3.
4 and 2.
4 and 2.
5 and 1.
5, I'll start another line. 5 and 1.
Sir, 6 and 0.
But we are not allowing 0, right? So we want each of these numbers to be at least 1. So,
Okay,
so we
thank
won't
you, sir.
allow 0 inside this.
Sir,
Thank you,
as
sir.
zero blocks will not make a tower.
Yeah, exactly. That is the sort of idea. That's another reason I talked about these towers first. Because, I mean, you see empty space and you don't say, that's a tower of 0 boxes.
Excuse me, sir. So
Yeah.
what should we do if they are asked to place 5 blocks in 3 towers?
Yes, we will look at that. But before that, do you have an answer for this? So for a general number n. So now, for example, I hope everyone agrees with these at least. So for 3, 4, 5, and 6 boxes, there are 2, 3, 4, 5 possibilities. So in general, so if I just give you, let's say, 565, n is 565, then what is the number of possibilities?
Sir,
Yeah.
sir, I found the pattern of n minus 1, and I also found a way to prove this, why it actually
Wonderful.
works.
Can you explain to all of us then?
Yeah. So basically, we are we are not gonna start from 0, but we are gonna start from 1, and then we are gonna go up to 1 plus n minus 1, because 1 plus n minus 1 would be equal to n, and then we
Okay,
would
so
go
you're
to 2 plus n minus 2. So
okay.
so if
1 second, let me just write down
yeah,
while you're saying this. So the first thing you're saying is 1 n minus 1. Then the second you said was 2 n minus 2. And then?
and then 3 n minus 3, and so on. So this would continue, like for so on. So this thing, so I noticed. Since you're starting from 1 and you're only going up to n minus 1, so from 1 to n there are n numbers, and
No,
then
no. So can you repeat the last thing that you said? You're only going up to?
n minus 1.
So what is the last thing that you should write over here? So this sequence you're saying 1 n minus 1, then 2
Yeah.
n minus 2,
So
3 n minus 3, up to 1.
last thing you would be writing is n minus 1 and 1.
Yes.
So so if you kept on going, then from 1 to n that would be n numbers. So from 1 to n minus 1, because you're going from 1 to n minus 1, like 1 of, so if you see in the first place of first number of every pair, so we would see 1 2 3 4 all the way up to n minus 1. So that means there are n minus 1 pairs.
Yes, wonderful. You have given an actual proof of this fact. Okay? So does anyone? Yeah.
Sir,
Continue.
I also found a way to find out the number of unordered pairs we could find out.
That we'll discuss a bit later, because ordered pairs are usually easier than unordered. So we'll talk about this for now. We'll talk about what you mean later. Okay. So it's a wonderful proof that you have given, because you have written down all the possibilities, and then the counting is sort of baked into the possibilities themselves, because this one over here is saying this is the first possibility. This 2 over here is saying this is the second possibility. This 3 over here is saying this is the third possibility. And so on, you keep going. And the last one that you write is this n minus 1, 1. So this is the n minus 1th possibility. Right? So the total number of possibilities, so the number of possibilities is n minus 1. So is there anyone who has any doubts about this?
Me, sir. Sir, if we counted 0 in it doesn't always have to start from 1. Then we would get n plus 1 possibilities, because we'll get 2 more added. But at the end, it will stay n and 0. So you cannot use that method over here, because the sum will be m. N and 0 are the two numbers. And n is not the number of possibilities. So I don't think this is specifically the same.
Yeah, but that's a different problem, right? But for this problem, you agree that this works.
Yes, sir.
Yeah. So for your problem, keep that in mind, because we are going to talk about that problem as well. Okay. But is there anyone who disagrees with this fact, that these are all the possibilities and hence the total number of possibilities is n minus 1?
So can you please explain the possibilities again?
Okay. So what we want to do is write down a pair of numbers. Okay. Each of these numbers has to be at least 1. Okay. So natural numbers, pair of natural numbers. Their sum should be n. Okay. So what all you have to do is figure out what the first number is, because let's say n is 55. Okay. Now, if I am constructing such a pair, and let's say the first term of that pair is 15, what should the second term be? If I want the sum to be 55?
40.
So
So
The
40.
other number should be 40.
Exactly. So the moment I give you the first number, the second number is automatic. It is just n minus whatever the first number is, right? So all that matters is what this first term over here is. Okay? The second term is automatic. So it is implied by what the first term is, if you have fixed n. So that is exactly what we are doing over here. Okay? We're just saying, okay, if the first term is 1, then the second term has to be n minus 1. If the first term is 2, the second term has to be n minus 2 because I want the sum to be n. If the first term is 3, the second term has to be n minus 3. And the only possibilities for the first term are 1, 2, 3, and so on, up to n minus 1. Okay? I won't include n because then my last term will become 0, but I'm not allowing that. I don't want to look at zeros for now. Right? So does that clarify?
Yes, sir, it clarifies.
Okay. So now what? So, okay, yeah, before we move on, is there anyone who disagrees with this? So it doesn't seem like it. Oh, Atar seems to disagree.
What's the logic behind this? For example, it should be for only even numbers because there'll be a point when two numbers are repeated.
Okay, so you're saying this formula does not work for odd numbers,
Yes.
but we started with an odd number, 5. And the answer we got was 4, which was matching. So let's look at the possibilities for 5. And so if n is equal to 5, we are doing exactly the same thing. If the first number is 1, the second number has to be 4. If the first number is 2, the second number has to be 3. If the first number is 3, second number has to be 2. If the first number is 4, the second number has to be 1. So, no,
Oh,
what's your
I
problem? If
understood. I understood. We're not going to do 0, 5. That's the reason.
Okay, yeah.
We have to minus 1.
Hmm. Okay. So if there is no one who has, if everyone understood this proof of this fact, now if you remember, I mentioned when we looked at this step 2, I said that one good thing to do when you are trying to solve a counting problem is to do examples and try to see if there's a pattern. But a very important part of this is don't be satisfied just when you see a pattern. Okay? For example, if I wrote all these down for let's say 3, 4, 5, 6, maybe I wrote up to 10 or 15. Okay, then I saw, okay, 2, 3, 4, 5, it is clearly just whatever number I have here minus 1. Right? So I'll see that list and I'll say, okay, the answer is n minus 1, and then I go home. That is not enough. Okay. When you see a pattern, try to make sure that you understand why that is the pattern. Okay. Don't just be happy with the fact that you found a pattern. Of course, it is very happy that if you find a pattern, but you should try to make sure you understand why that pattern is true. Okay. That is exactly what we did over here. Okay.
Sir,
We actually explicitly wrote, yeah.
sorry to interrupt, sir, but everyone, if you want to give an answer, like if suppose someone gives an answer, don't just spam the chat, same answer, everyone. So if suppose someone gives an answer, you can just thumbs up that answer so that you agree with him. Like, and like, don't spam the chat with unnecessary messages.
Yeah. Okay. So this is one thing that you have to be careful about, and it is very easy to sort of fall into this trap, especially in counting problems. Okay, when you see a pattern, the temptation is just to stop and say, okay, that pattern is the answer. Okay, but what I hope that you try to do, at least from now on in counting problems, is when you see a pattern, good that you can see a pattern, but don't be happy with just the fact that you found a pattern. Try to convince yourself that that pattern is actually true. Okay, and that is exactly what we did over here. Okay, so I noticed that a lot of you were writing down n-1 in the chat, which is great that you noticed the pattern, but always make sure that you understand why the pattern is true. Okay, that is a very important part of solving problems. And just as maybe a fun video that you can look at maybe after the session, I'm going to send something in the chat. So this is from one of my favorite channels, 3 Blue 1 Brown, which I strongly recommend that you look at. So maybe after this session, you can look at that video, which talks about a problem where it seems like a pattern is happening, and then the pattern breaks after some time. So don't ever be happy with just seeing a pattern. Be happy, but don't be too happy with seeing a pattern. Okay, always try to prove any pattern that you see. Okay, so that was just more of a, I don't know, a warning. But now let us try to look at a problem that a lot of you were talking about. So I'm going to drop the towers of boxes thing and just start talking about pairs of numbers. So what we were doing, let me just write that down. So if n is some natural number, there are n-1 ways. Sorry.
Then we can't see your screen.
Oh,
Okay, it's visible, sir. I think Rayansh, you have an internet issue on your side. Please just check. It's visible to all of us.
Yes.
Yeah, please continue, sir.
Visible.
Yeah. So what we have just shown is that if n is some natural number, there are n-1 ways to write. Okay, maybe I'm phrasing this wrong. The number, oh, sorry for writing and erasing so much stuff. So if n is some natural number, the number of pairs A, comma B, where A and B are natural and A plus B is equal to n is n-1. Okay. So this is what we just proved. Okay. So I hope everyone agrees with this. This is just a restatement of what we have just proved. And now what we are going to do is precisely what all of you were suggesting. What if instead of 2 towers, I had 3 towers? Okay. Which in this context would be, instead of just a pair of numbers, now I have a triple of numbers.
Sir, I don't quite understand what you wrote just now, sir.
Okay. So, yeah, maybe it was not very well written, but okay. So what were we doing over here? So you give some number n, and we are looking at these pairs, right?
Yes,
and
sir.
these pairs are just pairs of natural numbers a comma b. So a is this first number and b is the second number, where
Okay, sir.
a plus b is equal to n.
Yeah, okay, sir. Now I understand, sir.
Right? Yeah. So this is just a sort of restatement of what we have written down. So is there anyone who has a question about this, who does not understand this statement? Okay. So now this is what we have done, and hopefully everyone agrees now. We have seen a proof as well that this number is n-1. But now the question is, what if we had 3 numbers? Okay, what if we have a triple? Okay, let us again try this for n equal to 5. So n equal to 5, what you have to do is find the number of triples A, comma B, comma C,
Sir,
where
I have a doubt. Sir,
yeah,
Sir, can we repeat numbers like 113 is a combination?
yes, you can repeat numbers. So the only rules are that 0 is not allowed.
Yes,
Okay?
sir.
And the order does matter. So 113 is different from 131. So
Sir,
those are different. The order of the numbers does matter. Okay?
sir,
One second, let me just write this down. Maybe I'll just also say A, B, C are natural. Yeah, so someone wanted to
Sir,
ask
for
something.
the above statements, we can say it is also a predecessor of the number.
Yeah, sure. N minus 1 is called the predecessor of N. Yeah.
Sir, for this question, are we allowing 0 to be one of the numbers? Oh,
No,
sorry.
no zeros. So for all, at least for now, for all the questions that we look at, for example, here, these triples, they should all be natural numbers greater than equal to 1. Their sum should be 5. And just like before, I care about the order. Okay?
Sir, there are possible 6 I found.
Okay, so do you have them written down? Can you
Yes.
read them out to me then? Yes.
Sir, I also.
Sir, A equal to 1, B equal to 1, C equal to 3.
1, 1, 3. Yes. You can just say like 1, 1, 3. Like, I'll write it down.
Sir, then
Yeah.
1, 3, 1.
1, 3, 1.
Sir, then 3, 1, 1.
3, 1, 1.
Sir, then 1, 2, 2.
1, 2, 2.
2, 1, 2.
2, 1, 2.
And sir, lastly 2, 2, 1.
2, 2, 1.
Sir,
Sir,
this one.
sir, there are three more ways, sir.
Yes, can you tell me?
Sir, 3, 2, 1. Sorry, sir. Got confused.
Okay. Okay, so is there anyone who disagrees, who wants to add more of these triples here or wants to remove some triples from here, basically does not agree with the fact that there are 6 triples?
Athar,
Sir,
you have a disagreement? Okay, fine. Ayan?
Sir,
Okay, Ishan, continue.
Sir, I derived a formula for 2, sir, for doubles and triples, sir.
Yeah. So if you have a formula, just hold on. We are leading to that.
Aranya?
But hopefully everyone, yeah.
Sir, when we have n equal to 3, then we have one combination that 1, 1, 1. After that, if I take the first number as 2, can I take 0, 2, 1, 0?
No. So yes, wonderful question. For example, what you have just figured out is, so for n equal to 3, you have only one possibility, 1, 1, 1. So for n equal to 2, you can't do this, right? Because if I want each of my numbers to be greater than or equal to 1, then the sum should be at least 3, right? So for n equal to 2, there are zero ways to write these triples.
For n equal to 3, other than 1, 1, 1, is there anything? Can I write 2, 1, 0?
No, zeros are not allowed. Okay, but yes. So now again, let us try the same thing. Let us write down the table of possibilities. So hopefully everyone agrees with this 6 over here.
Sir, I found out the formula for this, for like.
Yeah. 1 second, hold on.
We're
not
doing
taking
the
formulas yet.
right now. Yeah.
We are just looking at experimentation.
Yeah, the other three of you, Advait, Pragya, and Ayan, do you
Sir, I
have
have a doubt.
disagreements or doubts? Okay,
Hmm.
Pragya has
Sir,
a
I
doubt.
have a doubt.
Yeah.
Sir, here the possibility is going
N plus 1.
Okay, but see, this is the thing I want about
No,
patterns.
Sir,
Try
it
to
is
do more
not N plus 1.
experimentation. Yes, yes, you're right.
Sir,
But try to do more experiment.
in
Okay,
4
yes.
boxes, it does not work.
Okay, so let us make a table. So n, the number of triples. So for n equal to, let's 3, 4, 5, 6, 7. So for n equal to 5, we have found 6 possibilities.
For 3, it is
So,
1.
yes, you mentioned for 3, it is 1. So let us try to fill up this table. So for 3
4,
equal
also
to 1,
I
I have,
found
no, 1 second. We'll take answers one by one. Don't just say your answer. So for 3 equal to 1, I hope everyone agrees. The only possibility is 1, 1, 1. Okay. So for n equal to 5, we have found the 6 possibilities which we have just written down. Now for n equal to 4, does someone have an answer for me what I should write here?
Sir,
Yes,
I
sir.
have an answer.
We wait.
Just raise your hand and then one of the volunteers will select you. Don't just unmute and
Yep. Okay, well, no one is to speak out of turn, please, or we will be forced to mute you. So, okay, fine. We'll take Shreyas. Shreyas is not talked in a lot of time.
Sir, for n equals to 4, there are 3 triplets.
Okay, so can you maybe list them out? So for n equal to 4,
Sir,
what are these triplets?
1, 1, 2.
1, 1, 2.
1, 2, 1.
1, 2, 1. Oh, sorry.
2, 1, 1.
And 2, 1, 1. Okay, so there are 3 possibilities. I've written 3 over here. Hopefully no one disagrees with that. For n equal to 6, does someone have an answer?
Arjun?
Okay, right. So for n equal to 6, we have exactly 10 triples.
10 triples. Okay, so this I'm not going to write down, but we'll see if I write it down. But has anyone done it for n equal to 7?
Yes, sir.
Sir, I've done it.
Okay.
Yeah.
Okay.
So,
Advait.
So for n equal to 7, it would be 15 because each and every number each and every amount of orders possible for each number would be would be n minus 2 would be the triangular number of n minus 2.
okay.
I think so.
So I'm assuming there are people here who don't know what triangular numbers are. So that answer maybe is not.
Excuse me,
But
sir.
let's see. Okay, yeah.
Excuse me, sir.
Yes,
Sir,
Shraddha.
I would rather express it as like n minus the triangular number of n minus 2 is just n minus 2 times n minus 1 by 2.
Okay. Okay, so, but before going into solutions, is there someone who does not understand where these numbers have come from or does not agree with any of the numbers written down over here?
Sir, I'm trying out the pairs for 6. I can't get 10, sir.
So
So for
for the
6,
pairs of 6,
sir,
yeah,
for
so
6, I
Yes,
got
sir.
9 possibilities.
Yes, sir.
okay, so let us write down for n equal to 6. So who was the one who said 10, if you remember?
Sir, I have the
Sir,
formula.
I said,
Okay, so then can you tell me the 10 possibilities?
okay, sir.
Hmm.
1, 1, 2, 3.
1, 2, 3.
1, 3, 2.
1, 3, 2.
2, 1, 3.
2, 3.
2, 3, 1.
2, 3, 1.
3, 1, 2.
3, 1, 2.
3, 2, 1.
3, 2, 1.
Triple 2.
triple two.
114.
114.
141.
141.
And 411.
411. So let's just make sure we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And hopefully there are no triples that are written more than once. And yeah, is there any other triple that someone wants to add? So if no one disagrees with this, then I guess maybe the people who got 9 probably just missed one of these.
Sir. Sir.
One second. Let me just ask again then. So is there anyone who does not understand how we have got these numbers or does not agree with any of these numbers?
Okay, so we
You
only
write all the 15 numbers for n equal to 7 because I get 14.
Sir,
Okay.
I got 15.
everybody please
How did you get those numbers?
everybody
Yeah, so
please come.
there you go ahead.
Okay, so everybody please calm down. Calm down. I only want people who have their hands raised to speak, and only people with disagreements to raise their hands.
Sir,
Priyansh,
Raise your hand and start
sir,
speaking
what
immediately.
formula did you get to get those numbers?
Okay, so 1 second. So the volunteers are telling you something. Don't just start speaking like that. So if you have a disagreement, raise your hand, then wait until your name is called. And then once your name is called, start talking. Okay, because it becomes unfair to other people who are raising their hand and waiting. Right. So if you just start talking.
Okay, so can Saman you start with the disagreement, please?
okay. I think Samanyu is waiting for a long time. So
Yeah.
Samanyu, you can speak.
Yes, sir. Sir,
Yeah.
I still don't understand what are triples and what formula you use to get those numbers, sir.
Okay. So actually answering your second question first, till now we're not using any formulas. We are just explicitly writing down all the possibilities and counting them. At least that's what I am doing. Hopefully most students are also doing. But what the triples we are counting are as follows. Okay. So for example, for n equal to 4, what we want to see are the possibilities of triples of numbers. And by triples of numbers, I just mean 3 numbers, okay, written in some order. So for example, here 1, 1, 2. And this n over here is just saying that their sum should be n. Okay. So here n equal to 4 means 1 plus 1 plus 2 is 4. Similarly, 1 plus 2 plus 1 is 4. So for each of these numbers n, we are just writing down all the possible ways in which we can get triples that sum to n. Okay? So for example, here 3, 1, 2 we have included because these are 3 numbers, all are natural, greater than equal to 1, and their sum is 3. Okay? And we care about the order in which the numbers are written. So even though, for example, if you see in these first 6 possibilities, it's just the same numbers 1, 2, 3, but we do care about how they are ordered.
Okay, sir.
Yeah, so that is what we are counting.
Thank you, sir.
So does anyone else have any other doubts or disagreements with this table we have?
Priyansh.
Sir, what formula did you use to get these numbers?
No formula, just writing down all these possibilities. For example, here n equal to 4, we wrote down all these possibilities. And so we counted that there are 3 of them. So we have written 3 over here. We have not yet come to a formula. So till now we are just doing experiments.
Sir, just
Yeah.
a heads up, we have 3 minutes, 2 minutes till the official session time ends. We can extend
Yeah,
up to 5 more minutes.
No, I would do that. So, okay. So what I would suggest that you do, let me just double check that these ones are correct. Yeah, okay. So the table of values written over here I'm going to spoil it for you and say these are correct. So if you have got different answers than these, for example, I heard that some people have a problem with this 15 over here. I think that you have either mistaken in your experimentations or you have forgotten one pair or included one pair by mistake or something like that. So these numbers are correct. So of course, I mean, I know you don't have much free time and it's a weekend. I don't expect you to do math again after this long session that you have had. But what we will do tomorrow is come back to this list of numbers and then we will see whether we can find any patterns over here. And crucially, we will also try to prove these patterns.
Sir, it is triangular numbers.
Okay, so some of you do have some suggestions of what these numbers are.
Yeah,
So
sir,
if you
they're
already,
triangular numbers.
yeah, so just 1 second, please don't
Well, they are
just start
triangle
talking.
numbers and they also have proof for it, sir. Why they are so?
Okay, so that is great. But what I would suggest is, so if you have a guess for the numbers, try to think of a proof. And also, I mean, try
Sir, I
to think
have
of different
forms.
questions. Yeah. So that's fine. Now we're not going to take any more formulas, experiments, numbers. The session is basically over. So I'm just going to talk about what we're going to do next. So in the next class, so there are people who are saying they have formulas for this. So in the next session, we will look at these formulas and try to prove them. And then, of course, I think that you can sort of guess what the next type of numbers we will be looking at. We looked at pairs, then we looked at pairs over here, then we looked at triples, and then of course I think you can guess what we are going to look at next. So yes, exactly. So we are going to keep continuing this pattern and hopefully find a pattern within the patterns that we have found. Okay? So that is what we will be doing tomorrow. So see you. Have a nice weekend. And I don't know what the procedure is. Is the 5 minutes extra supposed to be for me to stay and take questions, or is it just like if people
No,
don't
no. If you have something and you want to finish saying it just to stop on some sort of note, then you can just take the extra 5 minutes or 10 minutes. Otherwise,
Okay.
no.
Yeah. So I mean, if there is someone who wants to talk, I mean, hopefully not about this. I mean, whatever you want. I will be here for 5 more minutes, but basically, officially, the session is done. So
Oh, sir, I have a doubt.
Sir, you are not
yeah.
audible. Sir,
Sorry.
you are not audible.
Oh, okay.
Okay, no.
Can you hear me now?
So you're audible.
Yeah, he's
Okay.
completely audible.
Can we leave?
Yeah. The session is done. Yeah.
Okay,
Thank you,
so
sir.
you guys can join back at 4:45. Anyone with questions can stay back. And anyone without questions, lower your hand. Thank you.
Those who have questions can stay back and you can ask if you have time and sir has time.
Yeah, also, Tarya, Nivedita, and Yash. I mean, if you want to leave, that's fine. I mean, like, I don't want to force you
No,
to stay.
that's totally fine. Sir, if you have time, then they can ask questions.
Yeah.
Yeah. I have time. So, any questions? I'm fine.
Yes. So we'll start with Arjun.
Sir, I wanted to ask that in this concept, the whole concept of problems like these, counting numbers. So do we have to every time find a pattern or some? Is there compulsory to have a relation between some or the other?
So, for example, at least in the questions that I am going to present to you, of course, I have chosen them in a way that I know the answer and I know that there are patterns. But in general, there are several questions where, even the top mathematicians in the world can't find any patterns. So it's not like every problem will have a pattern. But what I would say is that when you get more used to, for example, in these problems, when you find this pattern, then the next time when you see something similar, hopefully it will click for you that, oh, I have seen this sort of thing before. Then you won't have to actually sit and write down all of this. That will immediately be there in your mind that what it is. So this is basically just saying that practicing more problems in counting will make you better at counting. So that is yeah.
Thank you, sir.
Yeah.
Okay, Meenakshi.
Sir, this is when you were explaining the doubts, you tried the first question and the extra questions that you gave There I found the pattern as the first one had one time, the second one had twice, the third one had twice, the fourth one had 3 times, the fifth one also had it 3 times, the sixth one had it 4 times, the seventh
Yeah,
one
so
had it 5 times. It went on like a pattern like this. I also saw that 4, the second one was a square number, 8 was a cube number, 16 was a square number, 32 was a cube number, like that, sir.
Yes, I think you are on the right track. And I would encourage that you experiment some more. I think you are having, I mean, if you like the problem, then you definitely seem to be on the right track. I don't want to spoil it and tell you what exactly the answer is, but at least from what you have said, it seems that you know, I mean, you are sort of on the right direction. So a nice job.
Thank you, sir.
Meenakshi, 32 is not a cube number. It's a power of 5. FYI.
Oh, I said cube. Oh, sorry.
Shraddha?
Sir, when you were talking and I continued this kind of table up to only 8, but then I wanted to find out the proof for why it was coming triangular. So when you were talking, I used what we had found in the previous 2 towers thing, and I found out the proof for this one too.
But don't spoil it for the people who are still trying. So
Okay.
we'll talk about it.
Can I share it in the next session?
Yeah, in the next session we'll talk about the solution schemes.
So even I found the proof, sir. Can I take a photo and share it in the Google Classroom, sir?
That still spoil it for everyone else trying. So how about we discuss it in the next class if sir brings it up? Is that okay?
Yeah.
So any other questions? No.
Can we leave?
Yeah, you can, sure.